you are gonna want a drink and a seat for this. I just found out yesterday there was this experiment that took place earlier this year where the double slit experiment was done in time. Admittedly, it took me a little bit to wrap my mind around this, so now that I kind of have, I'm gonna explain it and we're gonna ask some questions. In order to understand how the double slit experiment was done in time, we gotta go back to understand how it was done in space. Just a brief overview of the regular double slit experiment. Photons get shot through double slits. When the photons were not being observed, it created an interference pattern, which is like a wave. And when it was being observed, it collapsed its wave function into a particle. Things that we gleaned from this experiment is that light is weird because it's a wave and a particle. Photons exist in a state of superposition, meaning everywhere at once until it's observed, collapsed into that, and open the door for us to begin to understand consciousness and the observer effect, how what you see and observe creates your reality. Keep in mind this experiment's from 1801, quantum physics didn't really become like a thing until 1900, so before its time, we didn't really have a firm understanding of like what superposition was and how this was actually quantum mechanics at play. Alright, so how did they conduct this experiment in time? I had to borrow some screenshots from this person's YouTube page. Thank you. These are the two best videos on YouTube about it. I would recommend them both. This guy, I find him very endearing. I like his demeanor. So to set up this experiment to take place in time rather than space, the layout is kind of similar, okay? So they are shooting photons. The photons are going to go through slits, and it is going to hit a wall that collects data. It's a detector. Now, in the original double slit experiment, they are actual physical slits, spaces, gaps. In the new experiment, they are slits, but they are slits in time. So here's the setup. This is called a pump probe laser. One's pump, one's probe. And what's gonna happen is this one says probe laser. This one is constant. This is just a laser beam. And what that laser beam is gonna do at a constant rate is hit this material here. This is called ITO. ITO is indium tin oxide. It is the material that your touchscreen of your phone is made out of. What makes this special is that it can go from transparent to reflective. Are you with me? Indium tin oxide, the phone screen material, this is gonna go from transparent to reflective. But how? This laser here, the second one. This second laser is going to create the slits in time. So this laser is gonna come down, pew, pew, and when the light hits this ITO material, it'll be reflective instead of transparent. Very short amount of time, like 10 femtoseconds. This, I'm trying to stay away from the jargon. This is, a femtosecond is like 10 millionths of a billionth of a second. Really small. So when these two lasers, pew, pew, come down, slit in time. Because you can't see it in this image, but this is the first laser, the one that's constant. This image is better. So this constant one is coming down, then this second one is gonna go pew, pew. It's transparent until this one goes pew, and this laser starts going up because it went from transparent to reflective. Are you still with me? So this one is coming down at a constant rate. This one is gonna go pew, pew really quick. And when it goes pew, pew, it won't be transparent, it'll be reflective. So in that slight moment of pew, this beam will reflect instead of just go right through. That is the slit in time. That pew pew, that's these slits. So what they found is that in the experiment with time, it created the same interference pattern as when the experiment was done in space. So spatial version of interference pattern, or I guess if you want to see it here, spatial, and then time, when it hit the detector, it did the same interference pattern in the form of a frequency. When the above laser came down and went pew pew and made time slits, the original laser that was always going went up and created an interference pattern. The way that this was detected, the data it collected was in the form of a frequency, and that was shown by colors. Think of just like a prism, like when a light hits it's real pretty, like Pink Floyd. Here's how that relates to time. Because I wonder if you're thinking like, oh, that's measuring frequency or color, but that's the same thing as time. All right, so you've got the color spectrum. Actually here, so you've got the color spectrum, right? And every color has its own wavelength. You've got really slow, fat waves, a far distance between crest and trough of like the red. This is, I think it's like 440 hertz-ish, depending on the hue of red. And then you've got violet on the total opposite side. Very fast, which makes a shorter wavelength, squished together, crest and trough. Without getting too crazy in another tangent, frequency is inversely proportional to time. Okay? Not that like a human would really notice this, but technically, red wavelengths reach your eye faster than a violet wavelength would. You also see this in space with something that's called red shifting versus blue shifting. So we look at galaxies, shit that's really far away, and we know that it is moving away from us. It is moving away fast because it is red. Faster time, slower wavelength. Slow wavelength, red. Versus Sirius, the star Sirius in the sky. It's like, it's blue. You can't miss it. That is because Sirius is moving towards us. So, towards us, slower in time, inverse would be faster wavelength. If we need to go into like the nitty of that further, just let me know. Time is inversely proportional to frequency. Time is inversely proportional to frequency. So when this interference pattern takes place in the form of different colors, what is happening are different times at the same time. Are you with me? Should I repeat this? So the original double slit experiment, photons, pew, interference pattern, superposition. It is existing in all of the spaces at the same time. Pew, photons in the time slits. Hits, because it's different frequencies, but those are inversely proportional to time. Pew, spread. All of these times are existing at the same time. Time exists in a state of superposition. So that's the experiment. That's what they did. They found out that photons behave in the same way in space and in time. Now, they went on to talk about implications of like quantum technology, like light-powered computers and stuff, but I'm interested in something else. What I'm interested in specifically is like, how does the observer effect relate to that? If my conscious observation collapses a wave to a particle simply by observing it in space, does my consciousness simply by observing it create my time? Is my consciousness creating not only the spatial reality around me, but also the time reality around me? If I have the power to collapse a spatial wave, I also have the power to collapse time? Because if time exists in a place of superposition, like the experiment shows, then it's my conscious observation that makes it pinpoint. What does this say about the arrow of time? What does this say about entropy? And what would it look like if this experiment was done in both space and time? A time-space double-slit experiment. How much more intricate would the results be? And that's just stuff questioning time. I feel like this experiment also sheds a little bit more light on light. It kind of just like adds to this enigmatic nature of light. Light is a wave. Light is a particle. Light is the cosmic speed limit. However, light can not only move forwards but also backwards at the same time. Light is a force. Light's not just what you see. There's a power behind that. So like when you're looking in space and you look at the sun is light, and when it comes through space, through the vacuum, there's no light until it hits our atmosphere. Light is nothing visible until it has matter to hit and scatter against. That's how you see it. In the vacuum of space, there are so few particles that you can't see it, but it's still there. Light also transforms into energy. Humans also have biophotons. There is an invisible light inside of people. I just feel like this experiment not only invites curiosity to time, the relationship between space and time, but also invite us to be more curious about light. Last woo-woo-wah-wah questions is it possible that light photons can help us understand the potential of time travel? And is light a product of consciousness, or is consciousness a product of light? Things to think about. Have a good day.